Alright, so in this video, we are going to talk about what are significant figures and how to identify and how to count all the significant figures. So basically, when we talk about significant figures, it is just to make sure that when you do a big computation, when you do a big calculation, and when you use a bunch of digits, like for example right here, we have for 0.00 and so on, you are not going to over represent it. So basically, when doing significant figures, you're actually going to convert this bunch of digits here into smaller values. But when you do that, still you'll be having the same amount of value or having the same accuracy and having the same precision. Now, but before we go on in identifying significant figures, let's just now go first in identifying what are your leading zeros, what are your non-zeros, what are in between zeros, and what are trailing zeros. So here again we have the value of 0.0068230800. First, let's identify the leading zeros. Now, we all know from the word alone leading zeros. Of course, you can find these values on this place because these are zeros that is placed on the first part of the value, and this is actually an example of your leading values. Now next is your non-zeros. Now as we all know, when we talk about non-zeros, these are the values that it is not a non-zero. So any value that is not a zero will be your non-zero here. So here your non-zero is your 6, 8, 2, 3, and your 8. These are actually an example of your non-zero. Now let's talk about your in between zeros. In between zeros are those zeros that are actually located in between two non-zeros. So for example here, this is actually an example of your non or your in between zero here. Your zero here, because as we all know, your zero here is actually located in between your two non-zeros, which is your 3 and 8. So your zero here is actually an example of your in between zeros. Now let's go now with the last one, which is your trailing zeros. Now trailing zeros are actually zeros that are located on the far end of the value. So here you have your 0, 0 here. So these are example of your trailing zeros. So that's it. Now we go now with the rules in identifying and counting the significant figures. The first rule is that all non-zeros are significant. So let's have a set of examples here, like your 856, 2984, and your 19,256. Now, first thing to do to identify a significant figure is to count all non-zeros. So here for your first example, 856. Now, how many non-zeros do we have here? We all know that 8, 5, and 6 are not zero, so they are non-zero. And we all know that from this rule, non-zero are significant. So here we have 3 significant figures. Second example, 2984. And we all know these are actually example of non-zero. So automatically, all of them are significant figures. So here we have 4 significant figures. Your 2, 9, 8, and 4. How about on the third example? Now we have the value 9,256. Now, how many significant do we have here? First, count all the significant figures, or count all the non-zeros. So your 1, 9, 2, 5, 6. They are all non-zero. So count them down. We have 5 significant figures because all of them are non-zeros. Now we go now with your second rule. And your second rule is that zeros in between. Now we go now with your second rule, and your second rule is that zeros in between non-zeros are significant. Now let's have an example. Your 8,201 or 10,500 or 10,052. You have your 900,051 and 520. Now let's count all the significant figures here. Here in your first example, we have 8,201, and the first thing to do again is to count all the non-zeros. So here we have your 82, or we have your 8 and 2 and 1. Now how about the 0 here? Now we all know that this is an example of in between zeros, or in between zeros, and it is actually located in between non-zeros. You have your 2 here and you have your 1 here. So when this thing happen, your 0, even if it is a 0, it will be automatically significant because it is located in between non-zero, which is your 2 and 1. So here we have 4 significant figures. Now second example, count all the non-zeros here, 1, 5 and 2. So how about the zeros right here? Again, this is an example of in between zeros because they are located in between non-zero, your 1 and your 5. Now regardless of how many zeros you have, as long as it is in between two non-zeros, it will be significant. So here we have your 1, 0, 0, 5, 2. So all in all, we have 5 significant figures. Now third example, we have 900,051. How many significant figures do we have? First, count all the significant figures, or count all the non-zeros. Here we have 9, 5, 1. So how about these 3 zeros here? Again, as we all know, these zeros are actually located in between non-zero. So automatically, these 3 zeros will be significant. So here we have 6 significant figures. For example, we have 520. Again, count all the non-zeros. We have your 5 and 2. How about your 0 right here? Now, as we all know, zeros will be only significant if it is located between two non-zero. But here, your 0 is actually located on the far end of the value, or on the far end of your example. So here, this is not an example of your significant figures. So here we only have 2 significant figures. Let's go now with your third rule. Third rule is that leading zeros are not significant. So let's have a set of examples here. You have your 0.082, we have 0.1205, and we also have 0.0093. Okay, let's now look and identify how many significant figures do we have here. First example, we have your 0.082. First rule again, or first thing to do is to identify all the non-zeros. So we have your 8 and 2. Now how about these 2 zeros right here? Now applying the rules that we all know, leading zeros are not significant. So this is actually a leading zero. Again, why? Because it is located on the first part of the value. So this is not actually a significant figure. So we only have 2 significant figures here. How about on the second example? Again, count all the non-zeros. We have your 1, 2, and 5. Now, how about the 0 here? Is it significant or not? Not, because it is a leading 0. Now, how about your 0 here? Of course, it is a significant one because we all know it is located in between your non-zero, which is your 2 and 5. So here we only have 4 significant figures. Third example, 0.0093. Now count all the non-zeros. We have your 9 and 3, but how about these 3 zeros here? These 3 zeros here are actually example of leading zeros. So automatically these are not significant, so we only have two significant figures here. Fourth rule is that trailing zeros in whole number with the decimal shown are significant. Now let's have a set example. We have your 540 with a decimal point, and 500 with a decimal point. Now let's go and identify all the significant figures here. First example is we have your 540. Now first process, count all the significant or count all the non-zeros. We have your 5 and 4. Now how about the 0 here? Again, as we all know, all zeros are not significant, not unless it is located in both or in between non-zero. So here we only have 4 here, and there's no value right here. So we only have two significant figures here. Now how about on the second example? Now here we have a decimal point here. Now applying the fourth rule, it states that trailing zeros in whole number with the decimal point shown are significant. So this 0 is actually a significant one because it has a decimal point here. Now when it doesn't have decimal point, this 0 will not be significant. So here we have three significant figures. How about on the third part or third example? Now we have the 500 with a decimal point. First, count all the non-zeros. Now again, how about the two zeros here? As you can see, we have a decimal point here. So regardless of how many zeros you have, as long as it is placed before a decimal point, it will be significant. But with a whole number but with a non-zero here. So here we have three significant figures. Fifth rule is that zeros to the right of the decimal is actually significant. So we have an example here like your 93.00, 4.000, and we also have 0.0001 and 0.001 and 200.01. So let's now identify how many significant figures it has. First example, we have 93.00. First thing to do is count all the non-zeros. We have here 9 and 3, and we have a decimal point here. Now applying the first rule is that zeros to the right of the decimal are significant. So these zeros right here are actually located to the right of the decimal, right after the decimal. So here, these two zeros here are significant. So here we have four significant figures. How about on the second example? We have 4 here as a non-zero, and we also have zeros here. Now, as we all know, your 3 zeros here are located right after a decimal point. Now, automatically, these 3 zeros will be significant. So here we have also 4 significant figures. Now, how about on the third example? How many significant figures do we have? But first, count all the non-zeros. You have your 1. How about your zeros here? Now, as we all know, we have a decimal point here. But applying the third rule, which is leading zeros are not significant. So this is an example of a leading zero. So this is not a significant. How about these zeros right here? Of course, when it follows a decimal point and the value before the decimal point is a leading zero, or then these 3 zeros will not be significant. So here we only have 1 significant figure. So how about the fourth example? Again, count all these non-significant or non-zeros. We have your 1 again. And we all know your 0 right here is actually example of a leading zero. Now we all know leading zero is not significant. And so if it's not significant, the following zeros right after the decimal point will not also be significant. So here we only have one significant figure. Now on the fifth example, we have your 200.01. First, count all the non-zeros. You have your 2 and 1. Now how about your zeros right here and your 0 right here? Now you also have the decimal point here. Now as we all know, all zeros placed right before the decimal point are significant only if it follows a non-zero. So that's already 3 zeros here. Now how about your 0 is 1? Because it follows a decimal point and with a 0 here. Now the thing here, when it follows a decimal point and the value before the decimal point is a significant, whether it is a 0, whether it is a non-zero, this one will be significant. So here we have 5 significant figures. Now for the sixth rule is that trailing zeros are significant only if before or only if it follows leading non-zeros. Okay, for example, we have your 23.850. We also have your 10.250. Now let's count and identify all the significant figures here. For the first example, we have your 23.850. Now first identify all the non-zeros. You have your 2 and 3 and 5. Now how about the 0 here? It is significant or not? Now the thing here, trailing zeros are only significant if it follows leading non-zeros. So here your 0 will be significant because it follows a non-zero. So here we have 5 significant figures. Now same thing applies to the second example. We have your non-zeros such as your 1, 2, and 5. Now applying the fifth rule, we all know that we have a 0 here and we have a decimal point here. This 0 will only be significant if it follows a non-leading 0. So this 0 is actually an example of significant 1. So how about your 0 here? Now this trailing 0 will only be significant only if it follows a non-zero value. So here we have 1, 2, 3, 4, 5. So here we also have 5 significant figures. So that's it. Those are the 6 rules of identifying and counting all the significant figures. But before we end this one, we will be having first another set of examples. So we have your value like 0.1, 80, 80 with a decimal point, 80.000, 0.0025, and 20.00210. Now let's identify and count all the significant figures. First data is that we have 0.1. Again, count all the non-zeros. Now we have 1. Now how about the 0 here? Now as we all know, all leading zeros are not significant, so this is not an example of significant 1, so we only have 1 significant figure here. Second example, we have 80, and we all know 8 is a significant 1 because it is a non-zero. But how about the 0 here? Again, all trailing zeros are not significant, not unless it is located between 2 non-zeros. So here we only have 1 significant figure. Now what if we place a decimal point here? Then applying one of the rules that when 0 is placed right before a decimal point with a leading non-zero, then this 0 will be significant. So here we have 2 significant figures. For the example, we have 80.00. Now count first all the non-zero. We have your 8. Now how about your 0 here and how about your 0 here? knowing that we have a decimal point here. Now we all know this 0 here is actually a significant figure. How about the 0 right here? Now, when a trailing zeros follow a decimal point with a leading non-zero, then this tree is actually an example of significant figures. Now here we have 5 significant figures. How about on the fifth example, we have 0.0025. Now count all the significant. We have count all the non-zero. We have the 25 here. Now, how about the 0 here and how about the 0 here? We all know that leading zeros are not significant, so this is not as significant. And all zeros placed right after a decimal point and with a leading 0 will be not significant. So here is not significant. So here we only have 2 significant figures. Now how about on our last example? We have your 20.00210. Again, count all the non-zeros. We have your 2, 2, and 1. Now how about your 0 here? How about your 0 here? And how about your 0 here? Now as we all know, applying the same rule happen here and happen here. This 0 here will be significant because it follows a non-zero point, which is your 2, and you have your decimal here. Now applying the rules again, we all know that when there is a 0 right after the decimal point and it follows a leading non-zero, then this 0 right here will be significant. Now we all know also that trailing zeros with a leading non-zero will be significant also. So here is actually an example of significant. So all in all, we have 1, 2, 3, 4, 5, 6, 7. So we have 7 significant figures here. So that's it. That is how you get, or that is how you identify and count all the significant figures. Thank you for watching.